forward with our agenda, we have to speak now, or I have to give the floor to José Espí, representing the MARBEL project. José is the head of sustainable impact at Eurecat, and his talk will be focused on tracking sustainability in battery packs, a journey to life cycle assessment and eco-design, the case of MARBEL Horizon 2020 project. José, go ahead, please.
Hello, thank you so much. Welcome everybody, and good morning. I guess that you could enjoy my presentation regarding the MARBEL project. MARBEL, as it's an European Horizon Europe project focusing on the manufacturing and the assembly of innovative modular and reusable battery for electric vehicles. Aimed to introduce the environmental friendly and the lightweight solutions on the on this battery concept. Regarding that, and I think that it's a little bit recurrent with the main statements of the previous colleagues that have informed about the options on the innovative electromobility. I think that right now we have an increase on the CO2 emissions that are very linked, for example, on the gross domestic product, but we will have to reinforce the vision about the importance of the transportation and storage sector that allows more or less the 11% of the total CO2 emissions of the world. In that sense, it's really relevant that we could provide some solutions to try to decrease drastically these emissions. And what exactly in terms of the battery pack we have already noted that, for example, the weight of a typical battery ranges about 450 and 900 kilos. And regarding the materials that are already included, some of them, like for example, are lithium, it only covers 8 kilograms, or even cobalt ranges about 14 kilos, or even the use of manganese that are around 20 kilos, are more referred
José, I think we lost your microphone because we can't hear you any longer.
Meantime, for example, yes?
Now we can hear you. It's perfect. Go ahead.
Okay. I was muted, or? Okay. Well, I follow with my presentation. Around 25 and 40% of the rest of the different components of the battery, the metal casing, cables, the thermal management system, or even the battery management systems, it ranges from 25 until 40% of the total weight. In that sense, what was the main aim of the MARBEL? Trying to focus the different actions without having into account the nature of the cells, trying to determine, well, to conceptualize and manufacturing innovative vision of a modular, reusable battery for electric vehicles with some specific goals, trying to decrease in a 20% the weight of the total battery, to trying to reduce as well around 25% the charging time of such battery by the different improvements, trying to extend the battery life up to 300,000 kilometers, to try to conceptualize an easy and safe disassembly automatization, and or even trying to perform some improvements on the reparability, the second life transition, trying to adapt all the cells and vehicles, and focusing on the more or less that such goal more related to the webinar of today, trying to improve the life cycle perspective of the battery by reducing their impact in around 40%. Okay, in that sense, we have what we trying to implement on the MARBEL project. We have a division or trying to reduce that impacts, but as well at the same time trying to determine what are the links between the technical procedures of the project and on the different life cycle stages that we will trying to address. In that sense, by a cycle regarding the different hotspots identified, the strategies linked to that, the readaptation needed, trying to link the technical perspective with the environmental one, and the definition of specific actions, we tried to apply the methodology already more or less introduced by my colleague Violeta on the Fatigue4Light project, another one that are more linked to that such electromobility. This methodology has 4 differentiated stages, and in the step 1, we try to identify such hotspots regarding the life cycle, the different life cycle stages of the battery, but by the application of a benchmark analysis on the different conventional products, stages, and materials linked to a conventional battery, with the application for sure of the LCA and LCC methodologies in a simplified and a preliminary manner, trying to provide some feedback on the different project action and tasks, but not only by this application itself, but through an extensive compilation of different previous studies that will help us to try to determine an excellent starting point and the consolidation of this prior knowledge acquired. We define it in that sense different easily and understandable sheets that could be provided to the different project to the different partners of the project, trying to explain them what were the main hotspots and issues linked to different life cycle stages that, for example, in more detail here on the raw materials extraction and the components manufacturing, and an impact range by covering different batteries already developed in the past, that we more or less defined it at 30 or 50% of the total impact on the battery. What was the second step? The second step was the definition based in that hotspot analysis in a different co-design strategies in a very, very generic way. For example, the application of design for maintainability strategies, the lifetime extension of the battery, the use of different substitutes for critical raw materials, the consideration of second market processes, a portfolio of different strategies that, once again, was deployed in an Excel, not in an Excel, in different sheets, easily understandable by the different stakeholders between the project, trying to focalize what would be the different benefits of the strategies itself, what would be the relevance regarding the different stages, for sure, what will be the benefits from the environmental perspective, but as well from the cost one, a description of each strategy, the different innovative challenges that we will need to be overcome at the end of the project, and finally some different conclusions that allowed them out, or at least inspired the different partners trying to elucidate how these different strategies could be applied in our project. And This will be a key part on the project, because at the end we will try to align the different technological perspectives, the different technological procedures already more or less deployed or conceptualized in the proposal phase of the project, by trying to link that environmental perspective. In that sense, this third step will be dynamized by the application of several workshops, where all these different strategies and the different technological procedures of the whole consortium will be put in common, and trying to determine what would be the different synergies and the different ways to proceed to trying to cover all these different eco-design strategies, focusing on, for example, the effective material usage or the effective material usage in terms of the nature and so on. But at the end, and the fourth step, to determine a set of different specific actions that will be embedded with the lessons learned from the environmental perspective about what will be the best generic strategies to be deployed, that overcome in a set of different specific actions with certain relevance. Here you can be highlighted the most prominent on the application of the MARBEL project, the use of recycled and recyclable materials and the extrusion of the different aluminum profiles, or the reduction of copper material needed for the electronic components by the application of different strategies allowed to minimize the use of such metal, or even the introduction of, for example, wireless connection to the cells that allowed us to support the disassembly repairing options. All those different actions that nowadays are being implemented, and for that reason we will not have already now quantitative results, will allow us at the end of the project, by the application of such actions on the different life cycle stages, in a minimization of this impact by the help of, for sure, of the life cycle assessment methodology, and by including, for example, different perspectives from the cradle to grave, when we will try to analyze what will be the impact of the release of 1 kilowatt-hour of energy during the lifetime of the battery, but as well by including different strategies on the second life, by the application or by including by elucidating the impact by kilometer, trying to figure out the different conclusions and the results of the application of the life cycle assessment. In that sense, we understand that the most hardened power of the methodology itself is that allow us to quantify in a very transparent way the different effects and process of the products on the environment, because it's a very prominent tool that allow us that by different by the support on that methodology, on that eco-design methodology that I've already presented, that try to identify and prioritize what are the different elements with the most environmental impacts, and for sure for further improvement, and that allow us to develop robust and numerical supported impact reduction plans in for example, on the exploitation of the battery itself, on the different technologies emerged from the development of the project, and that at the same time allow us to reinforce all these different communication and reporting actions aligned with, for example, different standardized methods. Regarding all the different results already recovered from the application of the MARBEL project, that it's ongoing, and it is expected to be finalized next year. For example, we have already defined very well the different concepts related to lithium batteries in electric vehicles. The material selections, the weight considerations, the electrical composition, or even the vehicle lifespan or the saving derived from the reuse of such batteries, and the recovery of the different valuable elements are for sure key environmental concerns that have to be improved. And in a more abstract conclusion, we have already pointed out that the collaborative eco-design approach can lead to a more sustainable, efficient, and cost-effective solutions. Because at the end, if you have the chance to put in common the technical perspective and the environmental one, that more or less is not that easy work, and in this kind of different projects or proposals, it's very concerning. In that sense, the designers can identify and mitigate the environmental impacts at the stage. It allows to choosing materials with lower impact and with energy efficiency, or even increased recyclability, and finally to obtain a more eco-friendly battery pack. And even on the foster innovation, or on the collaborative perspective that can facilitate development of strategies, not only on the battery packs itself and the potentially extension of their lifespan, but even in the own day by day of the different companies and so on. And that's all. Thank you so much. I don't know if you have questions, or even we can perform them at the end of the webinar.
Thank you so much. Thank you so much, Jose, for speaking perfectly to.
You're welcome.
Also, yeah, I would say let's address any questions.